Welcome surfers, it is Joele and this is Rustlers. In this video, Atom 1.5, we are talking about flow control. Rust's control flow is an extension of its expression-oriented philosophy. Every conditional and pattern match produce always a value. In many languages, an if statement controls execution, but it doesn't return anything. Rust, however, use an expression. This meaning that the if always produce a value. Let's starting with the if statement example. We can define a variable called the temperature equal to 25. Let weather equal to weather equal to if temperature is greater than 13, we return hot. And else, if temperature is less than 10, we return cold. And else we can return mild. Okay, now we can print the weather variable and let's see what happened. Print line, the weather is something, weather, okay. Write this, check if there are evident problem. I think no. Okay, let's try to compile with cargo. Compile and run. We miss something, okay, at the end of the if statement. In this case, we need a semicolon because the if statement is included in the declaration of a variable, the weather variable. Let's try again. Perfect. The weather is mild. In this case, the entire if block yields a value that's bound to weather variable. Every branch of the if must return the same type, so hot, cold and mild in this case all match the same type, is a string slice. Rust enforces this rule and do this to guarantee type safety and to eliminate all kind of ambiguity. Next, there is another very exhaustive and important pattern matching tool in Rust. This pattern matching tool is the match. It's similar to a switch statement that you can find in other languages, but is much more powerful and is also safer. The compiler ensures that every possible input is handled. Let's try with an example. I can declare another variable called code equal 404 to match some kind of HTML error code. And now we can declare a message variable equal to match the code. If the code is equal to 200, okay, I can return okay, string slice. If the code is 404, I can return not found. Okay. And if the code is 500, I return internal server error. And with the underscore, I can declare a catch-all pattern. So this pattern is called in all cases that are not explicitly declared in the match. In this case, I can return unknown. Okay. Let's print the message. The HTML code is something. The variable is called message. Perfect. Okay, let's give a try to this code. Perfect. The HTML error code is not found in this case because we declared code as 404. Okay, each arm of the match, as you can see, is an expression, and just like if, the whole match returns always a value. Rust requires that every possible case is covered. So if you forgot one possible case, the compiler won't let you code compile. For example, if we remove the catch-all pattern, let's see what the compiler say. There are patterns that are not covered. If we add again this catch-all pattern, the compiler have not to complain, have nothing to say. Try again. Okay, now the code is good also for the compiler. Match can also destructure and bind data directly. In this case, match become a very powerful and very expressive way to destructure data. To create an example of this, we can declare an enumeration. Enum called packet. With three possible value: quit, move, with two coordinates, x, I32, and y, also I32. And also echo, that take a string as parameter. Okay. Now I can write a function called process packet. Okay. I, in this case, can match the message. If message is quit, I simply print a message, print line exit. Okay, I miss this. If the message is move with x and y values, I can print these couple of values. Print line move to something x and y. Okay. And if the message is echo text, in this case I can print echo something text. Okay. And now in I miss another. Okay, perfect. Now the function is complete, and in the main function I can process something. Just to see this match in action, I can process a packet. I here use the wrong name, it's not a message but is packet. Okay. I can process a packet of type move with x equal to 10 and y equal to 12. Okay, let's run and compile. Match message. Okay, let's see the message. This is the problem. Okay. Okay, now I can see the match in action. I see the string move to 10 and 12. In this case, each pattern not only checks which variant of the enum we are dealing of, but also extract data from it. In this case, extract x and y integer values. This is a very powerful way to work with structured data while keeping the logic very clear and while keeping the code absolutely type safe. Sometimes there are occasions in which you only care about one specific pattern and you don't want to handle everything else. So using match in this case is not an elegant option. For that, Rust provides if-let expression, which is a concise version of a single match arm. For example, I can declare another variable here called maybe number equal to sum 42 is our magic number. Sum is one variant of the option enumeration. Is an enumeration that is contained in the standard library. You use sum when there is a valid value, and you can use none when there isn't a value. In this case, we can use our if-let shortland to check if our maybe number is a number or not. So, if let some number equal to maybe number, if there is a number, I can print there is a number. N. If there isn't a number inside maybe number, I can print simply no number baby. Okay. Give a try to this code. As you can see, the code print there is a number. We can test the other arm of the match. If I declare maybe number none, and I also need my option type because it's not explicit. Perfect. Now, as you can see, the match work very good, and the program print no number baby because my maybe number option is none. Okay. The key takeaway is that Rust's flow control unifies logic and the structure of a program. If and match, as you can see, are expressions that yield values. So exhaustiveness is guaranteed by the compiler. Patterns can bind, can destructure, and can also filter data all at once. So the control flow in Rust becomes very elegant and a type-safe decision tree rather than a series of runtime conditions. For today's video it's all. See you in the next Rustlers Atom, and don't forget to keep your thinking cap on.